Hey folks, thank you so much for joining this talk. I am Bhumik.
Hey everyone, this is Deepak from the Apple Ray team. All right,
Let's start.
okay, let's start this session by looking at the anatomy of an agent. And we'll also cover what a production agent engine demands. And then we'll see how Ray fits in. Followed by that, we'll see some interesting aspects of Ray serve in action. Okay, this should be pretty familiar space. This slide covers the basic building blocks of an agent. As a developer, we generally declare or define an agent by specifying certain things, tools, LLMs, and some sort of agentic nodes. These gives the agents their capabilities to reason, tool call, access resources. Then we compose all of these together, which gives the agent a brain, basically ability to orchestrate calls, decision making, state management, and so on. And finally, the developer would turn the agent into a servable application by using some sort of fast API. Double clicking into the agent is an example. It's a familiar picture. You may have an agent that can be used to interact and gets information about payments. This simple payment agent, you ask the agent question about what's my payment status. In this case, the tools available in the agent is basically used to pass to the LLM. LLM would make a decision on which tools to use. In this case, maybe a get payment status. And it would ask the agent to execute those calls, use all those resources and results to respond back to the user. Let's keep this in context and see what is required when you want to deploy an agent in a production grade environment. The agent engine needs to be framework agnostic, right? You might be using popular open source frameworks to develop an agent, and all of those resources should be deployable. Then it needs to be developer friendly. The code you write in local, you should be able to take it to production without making significant changes from dev to prod. Then once you run something in prod, it has to auto-scale, be fault tolerant, and then it comes with additional responsibilities. Agents also are basically services, so you have to manage access to agents. And with all of this comes other responsibilities of observability, providing logs, traces, metrics, while everything is happening at scale. This is something very familiar. Agents have memory. You need to have capabilities to wire in short-term memory, long-term memory, semantics, general knowledge. And most often agents are highly network bound. They orchestrate a lot of calls. Now, when you keep these requirements in mind and look at what Ray has to offer, there is a lot of out-of-the-box capabilities that Ray ships. I think a lot of the features were highlighted in the keynote today. The Ray cluster gives you a way to basically abstract all the resources, heterogeneous resources, and then auto-scale. Ray serve basically helps us turn a simple API into a fast API that can basically auto-scale to traffic demands and also be fault tolerant. And Ray jobs are great at running async tasks. Finally, everything is observed. Basically, we get metrics, traces, all of these are coming out of the box. So Ray is a great fit. Now I'll turn over to Bhumik, who will take us through the journey of building Ray serve for agent.
All right, let's see how Ray serve can be used to actually deploy an agent at scale. Here is an end-to-end journey. Once you have wrote an agent, how would you take it from your local to a deployed stage? The first thing is that you want to expose this agent as a fast API application. This would allow the agent to be hosted on Ray serve. That is the next step. Once I have a fast API based application, I can easily wrap it around and make a Ray serve application. The next step here is that I would like to run this locally and iterate fast, make changes, validate things, and then keep adding more and more features until I'm ready to take it to the next stage. RayServe really allows everybody with the capability to do this very fast and very seamlessly. The next stage is, once I have locally tested everything, I may want to configure things for different environments. RayServe allows us to add configurations which are specifically suited for autoscaling, fault tolerance, and much more. Then I also want to make sure that I'm able to observe the application thoroughly. I can emit some custom metrics. I can look at some out-of-the-box metrics which Ray provides. I would like to see the logs. Ray comes with this Ray dashboard, which provides a lot of visibility into your workloads. And last is that I would like to deploy this application onto Kubernetes. So Ray has this Ray service CRD, which you can prepare and then deploy to Kubernetes. Now let's see each of this step in more detail. The first step is building a fast API application. So here I am just showing a simple pseudocode where I have taken an agent and I'm wrapping this agent into a fast API application, and I'm exposing two endpoints. First endpoint is /agent here, which is basically invoking the agent by taking the user query. Then the next endpoint is a health agent, which is just for example purpose here, but you can add more and more routes like this in your fast API to expose different capabilities of the agent. Now, once I have the agent wrapped as the fast API, all I need to do is specify this fast API application as my Ray serve deployment, specify this as the serve ingress, and that's all. Writing this few lines of code would let me run this application on Ray serve. Here I'm only sharing a few high-level features, but depending on the use case and the requirements, you can explore features like WebSockets, streaming response, and much more, which is available through RayServe. Now, I would like to quickly also run this and validate if things are looking good. Once I have the RayServe agent ready, all I need to do is serve run and specify the Python module name along with the variable name of the Ray agent, and it will start the Ray service right on my local. It also exposes the Ray dashboard, which I can view and understand different things about the service. This is a great way to iterate faster and build more stuff on your local. Now, RayServe, one of the biggest features is that it comes with auto-scaling and fault tolerance configurations right off the box. There are two ways to provide these configurations. One is in the code and another is in this serve config v2. So in the previous example, I showed how the different configurations can be written inside the code in the deployment annotations. Here I am showing how those configurations can be exported using serve build command and can be stored as a YAML file. Now, depending on the environment you are working in, you can change these configurations, you can add more configurations per the requirements of that environment. I'll show how this serve config v2 can be used in the next stage of Kubernetes deployment. Now, this is a very simple snapshot of the Ray dashboard, but there are many frames which go underneath here. The Ray dashboard is one of the best tools for observing your Ray application. It can provide me with the underlying resource utilization, the logs, the metrics, and many features like that. Once I am satisfied with everything, then I can package the whole RayServe application as a Ray service CRD. The way it works is that on Kubernetes, we can deploy a kuberay operator, which is able to provision the custom resource definition related to Ray service. Inside Ray service definition, there are two major sets of configurations. First is the Ray cluster configuration, where you can specify the underlying compute requirements. For example, the resources for the head pod, the worker pod, environment variables. You can also specify different sidecars you want to spin up here, specify your own custom container images, and so on. And inside the Ray serve configurations, you can specify the serve config YAML, which I showed in the previous slide. Once you package everything as a Ray service YAML, you can just run the kubectl apply command, and have your Ray service deployed on Kubernetes. Let's put everything together now. What we did here was that we leveraged the power of Ray cluster for the resource isolation. All we were able to specify is how many CPUs, memory, all sorts of things we needed, and Ray cluster took care of that. On top of Ray cluster, we deployed the Ray serve application where we abstracted the agent as a fast API application, and we didn't have to worry about any sort of orchestration behind the scenes. And last but not the least, with the Ray dashboard, we were able to see how the service is behaving, how things are looking, so that we are more confident both on our local and when the service is also deployed at scale. So all of this thing make Ray a very suitable framework for deploying your agents. With that, we would like to conclude. Thank you so much for your time.